Okay, let's go over these GetAFive questions really quickly. This is on the first video, the limits of functions. Here, they give us this kind of piecewise function. They don't give us the equations. They just give us the graph, and they ask which of the following limits exist. So as we approach A of this function, do we have a limit? Yes, we do, because we're approaching just one specific point. So 1 does have a limit. As we approach B, from the left side, we're approaching this value down here. From the right side, we're approaching this value up here. So as we approach B, we do not have a limit. And as we approach C, there's nothing going on at C. C is just a regular point. We're approaching the same Y value. So it is 1 and 3 have limits. Okay, 1 and 3 only. Let me erase my ink, and then we'll go from there. Number 2. Oh, actually. Number 2, let's look at this one. We've got, for which of the following graphs is it true that the limit as we approach 3 is 4? So for the first graph, we are not approaching 4. We do have a limit, but we're not approaching 4. For the second graph, we're approaching 2 different values, so it's definitely not that one. And then the third one, we are approaching 4 as x approaches 3, so this one is 3 only. Okay, let's look at number 3. Suppose the table of values represents the behavior of a certain function. What conclusion is supported? So let's look at that. What x value are we approaching? These x values are getting closer and closer to 1. So it's definitely not the first one, and it's definitely not the last one. Looking at the differences here, we are approaching 1 from which side? It's left side. And as we're approaching it from the left side, those y values are getting closer and closer to 3. So there is our answer there. Number 4, suppose the table of values, same kind of idea. Let's see here, what are our x values getting closer to? Our x values are getting closer to 0. They're getting smaller and smaller, so our x values are approaching 0. So eliminate that one, eliminate that one. We're approaching 0. We're not approaching 0 from both sides. So it's looking like the first one, but let's make sure our y values are indeed getting closer and closer to 1. So those are the questions for this first batch. Let's look at the next set of questions on limits found algebraically, part 2. All right, so this first one right here, we can see that this is going to be a factoring problem. The limit, let me make that smaller. The limit as x approaches 2, factor out a 2 from the top, factor out the difference of perfect squares on the bottom. So those cancel, so we've got the limit as x approaches 2 of 2 over x plus 2. Now we can plug in 2, and so that's 2 over 4, which is, of course, 1/2. Okay, next one. I'm not sure what's up with the dollar sign, but this is a complex fraction problem. So we need to multiply by 5x. Everything gets multiplied by 5x because that's the only thing we have in our denominators. So here the x's cancel, so we get 5. Here the 5's cancel, so we've got minus x over In the bottom, remember, we don't multiply out the bottom. Now, this is not exactly the form we need to be in. It needs to be in, because the numerator there, this pen's going a little nuts. The numerator there, we need to flip that around, because we really want that to be x minus 5. So we need to factor out that negative so we can cancel it with the bottom, and then we can plug in 5, so we get negative 1 over 25. Okay, I do not like this one. Negative 1 over 25. Okay, number 3. Let me go back to this pen. All right, so this is the one where we multiply by the conjugate. All right, so kind of a lengthy conjugate here. Square root of x plus h plus 3 plus the square root of x plus 3. Square root of x plus h plus 3 plus the square root of x plus 3. So when we multiply it on the top, still have our limit notation here. When we multiply it on the top, the square roots cancel, so we've got x plus h plus 3. The outside and the inside terms cancel, so we've got minus x plus 3. Notice I put it in parentheses. And we don't multiply out the bottom, because when we distribute this negative here, we've got x minus x, so that goes away, and we've got 3 minus 3, that goes away, so we just have an h. So our problem can be canceled in the next step. So we've got 1 over the square root of x plus h plus 3 plus the square root of x plus 3. Then we can plug in 0 for h. So that's x plus 0 plus 3, which is the same as just x plus 3. So we have 2 of the same square roots down there in the bottom. So it is this answer choice right here. Don't forget, you don't have to rationalize in calculus. So we are done at that point. Okay, number 4. Number 4. All right, so this is the one where you got to take what you know and manipulate it. So we're going to break this up, because I see sine x over x. So I'm going to pair those together. And I'm going to put cosine here, and I'm going to put that 4 as a 1/4. So we know you're supposed to memorize the limit as x approaches 0 of sine of x over x is 1. We can plug 0 into cosine. The cosine of 0 is 1, so we've got 1 times 1 times 1/4. So that is where the answer of 1/4 comes from.